Welcome to the 12th session of Basic Mathematical Analysis. In this session, we will be discussing finite and infinite set, which is in the section 1.3 of our text. First, we have to define certain things. First, I am defining an empty set has 0 elements. This is a definition. I am defining that an empty set is said to have 0 elements. And a set is said to have n elements if there is a bijection between 1, 2, 3, etc. up to n and s. So, either you have to define a bijection from 1, 2, 3, etc. up to n to s, or you have to define a bijection from s to 1, 2, 3, etc. up to n. Okay. And a set is said to be finite if it is either it should be empty or it should contain n elements for some n element of natural numbers. Either it is an empty set or it contains n elements for some n element of natural numbers. That is a finite set. And we define infinite set as a set which is not finite. That's easy. An infinite set is a set which is not finite. That is, these all the four are definitions. So, we have to be little more careful about 2 and 3. Suppose I have a set A equal to A, B, C, D, E. We know that there are 5 elements in this set. So that I will be defining a bijection from 1, 2, 3, 4, 5 to A, B, C, D, E. I will call this as N5 because it is a subset of natural numbers and it contains 5 elements, first 5 elements of natural numbers. So N5 to A, I have a bijection. 1 maps to A, 2 maps to B, 3 maps to C, 4 maps to D, 5 maps to E. And you can define several bijections from N5 to A. I am taking only one. So there is a bijection between, and I will call this as F. So there is a bijection F from N5 to A. Okay, then by our definition, by the second definition, we can say that A contains 5 elements. A contains 5 elements. And also by the third definition, a set is said to be finite if it is either empty or contains n elements for some n element of natural numbers. So 5 is a natural number and A contains 5 elements, so A is finite. Okay. Now we have to move on to some theorems. The first theorem is uniqueness theorem. And this uniqueness theorem says that if S is a non-empty finite set, then the number of elements in S is a unique number in natural numbers. So S not equal to 5 is a finite set. So we know that a set is finite if it is either empty or it contains n elements for some n element of natural numbers. So here S is non-empty. Therefore, S should contain n elements for some n element of natural numbers, and the theorem says that n is a unique number. The number of elements in S is a unique number in natural numbers. unique element of n. This is what uniqueness theorem says. And the next theorem is also a trivial one. You are very much familiar with that. This theorem says that set of all natural numbers is an infinite set, because it is not possible to define a bijection f from a proper subset, a finite proper subset of n to n. There does not exist a bijection between nm and n for any m element of natural numbers. So, set of all natural numbers is a finite set. This is what theorem 1.3.3 says. Okay, I am stopping this session here because next is a theorem and I cannot finish within the time limit. So I will take the next theorem in our next session. So study the definition for set contains n elements and definition for finite set carefully, so that this is the basis for the next year. So thank you.